115 commercial reactors, 48 experimental reactors, 250 research reactors. According to the World Nuclear Association, this is how many nuclear reactors have retired from operation. Ladies and gentlemen, these stats show just how important it is to invest in nuclear decommissioning technologies because of the already large market that's steadily rising as more and more reactors retire from operation. One of the biggest concerns facing decommissioning is reducing airborne contamination in areas with high radiological contamination zoning. If you look at a typical work plan which involves decontaminating and removing equipment, we may see the following steps. I've underlined the two important steps. First, a contamination stabilizer is dispersed into the area as a fog to make the contaminant particles really sticky and adhere to the surfaces of walls. Then, a contamination fixative is painted on the surface to lock the contaminants into place. Unfortunately, both these methods have their limitation, and the method of applying the contamination stabilizer does not provide good adhesion on all surfaces. And the method of applying the contamination fixatives is one of the most dose-intensive processes. If you take a look at the whole body collective radiological exposure for each of these steps, you will see that the step to apply the contamination fixative is one of the most dose-intensive process because you're dressing up a worker in full Tyvek and getting them to paint all the surfaces that need to be fixed. In the fluid engineering group, we look at more effective ways at applying these contaminant suppressants. One very promising method is to apply these fixatives as a fog. This will prevent the worker from having to go out into the field to paint all the surfaces. We've identified a few such fixatives that can be dispersed as a fog, and here in our test rig, we are dispersing a few of these fixatives and studying the fluid dynamics of the entrained droplet flows. The green fog that you see in our test rig is one of the fixatives being dispersed as a fog. Our goal is to study the fluid dynamics of the entrained droplet flows so that we can ensure the best coverage of the fixative on all surfaces. We're also studying the use of ultrasonic transducers to disperse the contaminant stabilizer as droplets because this method of creating droplets is more effective at producing smaller droplets and causing the droplets to adhere to surfaces. The aerosol test facility here at CNL is an excellent place to test these fogs in a controlled environment where we do not have to fear the fog being released into the environment. Here we see such a test being performed in the aerosol test facility. And if you're successful with these tests, then we can potentially reduce the high contamination we've seen in decommissioning steps that we saw earlier. This is also an excellent opportunity for collaboration for different groups within CNL and groups outside of CNL, such as in Idaho National Labs. Thank you very much.